Welcome, everyone. Today, we are embarking on a fascinating journey through history, exploring how different civilizations shaped the development of mathematics. From ancient China to medieval Europe, each left a legacy that continues to influence our world today. Math is not just about numbers. It is a universal language developed across time and cultures. Let's dive into the math stories behind four influential civilizations. As we walk through this timeline, think about how each culture responded to its own unique needs and challenge with mathematical innovations that still affect us today. In ancient China, mathematics was used as a tool to maintain order, whether in civil engineering, agriculture, or governance. One of the most influential texts was the nine chapters on the mathematical art, which included 246 problems, ranging from calculating areas and volumes to solving systems of equations. The Chinese used counting rods arranged on boards, especially early matrices, to solve linear equations. These techniques show how their mathematics was not just theoretical but rooted in everyday problem solving with a highly algorithmic approach. Chinese scholars were also keen on standardizing measurements and timekeeping, which helped unify a vast and diverse empire through consistent application of math. India's mathematical legacy is profound. Their place value system, where the position of a digit determines its value, and the invention of zero revolutionized numerical computation. Aryabhatta was a pioneer in astronomy and trigonometry, proposing that Earth rotates on its axis. Brahmagupta in the 7th century defined zero as a number and explained how to compute with negative values, centuries ahead of Europe. Bhaskara II later elaborated on algebra and was the first to write about the concept of infinity and differential calculus. Their legacy laid the groundwork for modern arithmetic and algebra. Beyond practical tools, Indian mathematicians embraced philosophical questions. How does the infinite behave? How do abstract patterns manifest in the physical world? Their math was deeply tied to both scientific and spiritual exploration. The Islamic Golden Age was a golden bridge of knowledge. Scholars in Baghdad, Cairo, and Cordoba translated and preserved Greek and Indian texts, making innovations of their own. Al-Khwarizmi's book on algebra, Al-Kitab al-Mukhtasar fi Hisab al-Jabbar wal-Maqabala, gave algebra its name and outlined systematic methods for solving equations. Islamic mathematicians developed sophisticated trigonometric tables, improved numerical notation, and introduced the decimal point. Their scholarship was driven by both religious and scientific purposes, such as determining prayer times and geographic direction, which made math a vital daily tool. Moreover, institutions like the House of Wisdom in Baghdad functioned as research centers where scholars debated, collaborated, and pushed the boundaries of mathematical understanding in ways that still resonate in modern science. Europe's early medieval period saw limited mathematical innovation. But the tides turned with the translation of Arabic works into Latin. Leonardo of Pisa, known as Fibonacci, helped introduce Hindu Arabic numerals through his book Liber Apache in 1202, making calculation far more efficient than with the Roman numerals. Education was structured around the quadrivium, which emphasized math's role in understanding the universe. These efforts laid the groundwork for the mathematical revolution of the Renaissance, fueling scientific progress. Over time, universities in places like Paris and Bologna became centers of learning where scholars reconnected with classical ideas and transformed them through innovation. Math began to be seen not just as a practical tool, but as a field of deep intellectual pursuit. Let's take a broader look. Each civilization contributed uniquely to mathematics. Chinese structured methods influenced computation. India gave us the concept of zero and symbolic manipulation. The Islamic world preserved and extended this knowledge, and Europe unified and built upon it. And math then is a shared human endeavor, an intellectual legacy passed hand to hand across continents and centuries. Seeing this web of interaction helps us appreciate that mathematical innovation doesn't occur in isolation. It's shaped by culture, trade, conquest, and curiosity. Understanding the history of math helps us see it not as a rigid subject, but as a living story of discovery, creativity, and collaboration. Every equation and concept we learn today has a story behind it, crafted by brilliant minds from different times and places. And now it's our turn to carry that story forward. Thank you for joining me on this historical journey through the evolution of mathematics. May it inspire you to see math not just as a school subject, but as a reflection of human thought and possibility across centuries.